The purpose of Lab 1 is to demonstrate the difference that shape makes in the beams. Students are going to use folded tag board or manila envelopes in order to look at two different shape beams, one that's been folded wide and one that's tall and thin. This also offers an opportunity to go between the solid B-pillar formation and the rectangular shape we need the beams to be for the labs to be effective. Students can stack materials on these beams to see how much mass the beams will hold before they collapse, showing the difference that shape makes between the two. Another option is to poke a hole in the beam itself. You can distribute the weight with a simple washer and hang a cup and start adding water as your mass to see how much water the beam will hold before it collapses.
Ooh, we need more water. Nope, we got it. Ooh, and it didn't spill, even better.
Even better. Based on their experience flexing the meter stick, students are asked to predict which beam will support more weight before it collapses. You could use coins, washers, the water, all sorts of options to test the beam itself. Another option for Lab 1 is to ask students, if there were a crash, would your doors be wide open or would there be some support offered to the B-pillar through the doors of the car? So you can sandwich the beam between two objects, dictionaries or books, bricks if you've got them, and go ahead and add weight and see if there's a difference between the B-pillar collapse with doors open versus doors closed. I think you'll find that students find the amount of weight that they can put on the pillars pretty impressive.
So the weights that we're using here are actually cut up pieces of tin, so it's quite heavy. And I'm trying to center them along the center line of the beam as best I can. The other way to do this is to support the beam as we did with the cup hanging below and then add the supports to the side. And so you can hang a fairly large container and use a lot of sand or water to add quite a bit of mass. So I'm going to see if I can start stacking tin nuggets. Not very well. So we can mass these tin nuggets, but there's probably close to half a kilogram on there now. And it's still hanging in there. So no collapse. So this lab was designed to bridge the gap between the B-pillar, which is constructed of sheet metal, and the engineering test requirement, which was the crash test, with the doors closed, and then the work that we'll be doing to engineer a lightweight beam out of solid rectangular shapes. So I've bent the beam, but it hasn't completely collapsed.